Hello and welcome to another LeetCode problem. So today we're going to be doing problem number 134, gas station. It's definitely a tricky problem. I'd say it's not too hard once you get the tricks, but it does use something that's pretty rare to see, so it's going to be good to use. So let's read the problem. There are n gas stations along a circular route where the amount of gas at the I station is gas I. You have a car with an unlimited gas tank, and it cost I of gas to travel from the I station to the next station. You begin the journey with an empty tank. Given two integer arrays, gas and cost, return the starting gas station's index if you can travel around the circuit once in the clockwise direction, otherwise return -1. If there is a solution, it's guaranteed to be unique. And this is important to be able to solve this problem because we can just figure out like what's the best solution to start at. So first of all, let's actually begin with example 2. And let's figure something out here. So let's say our gas is 234 and our cost is 343. And let's just ask ourselves, it doesn't really matter where we start, but let's just say we start at index 1 or index 0. What would be the cost to make a loop? So the cost to make a loop would be the sum of this cost array, right? We'd have to pay this cost and this cost and this cost, and then we'd end up over here. And so if that's the case, then our cost here is 10. Now, how much gas do we have total? Well, we have 2, we have 3, we have 4. So our gas here is 9. So if the cost to make a loop is 10, no matter where we start, right? Anywhere. Like let's say we start here, the cost is still 10. Here, the cost is still 10 no matter what. And so if our total gas is 9 and the cost is 10, we know right away that we can't actually complete a loop. And so that's going to be an important base case. So if sum of G is less than cost, say sum of C maybe, of C, then we have an invalid solution. Okay, so that's one thing. Now let's look at example 1. Let's go back to it. So we have G. Let's look at it. 1, 2, 3, 4, 5. And then let's look at the cost. So we have 3, 4, 5, 1, 2. And let's just actually create one more array, and that's going to be how much gas we gain or lose. So let's call that a net maybe. And the net is going to be the gas minus the cost, right? So -2 here. Okay, then we have -2 again, then we have, -2 again, right? Then we have 3, we have 3. So this is the net gas. So let's just try to start at any index with a negative net gas. Well, like if we start at 1, we get 1 gas. So wherever we start, if our gas is lower than cost, we can't go to the next thing because we fill up with 2 and then we travel 4, so doesn't work. We fill up with 3, we travel 5, that doesn't work. So from these positive values, where does it make sense, if you just think about it, where does it make sense to start if we're only guaranteed to have one solution? So only one of these indices works. Well, we'd want to start at the index that maximizes our gas, right, to start off. Where's that going to be? It's going to be right here, right? Because we would get 3 gas, then we would go here again and we would get 3 gas. So we'd end up with 6 gas once we started here. Or if we start here, we would have 3 gas. And then we would start losing gas. So you can kind of see that you want to start at the index if there's only one that maximizes our gas. Now, what index actually maximizes our gas? And so the way to tell that is no matter, like, let's look at some other solution, right? I'm just going to print a brand new, so this was like the differences. Right, so this is like the number of gas, that's the difference. So let's just put in some other numbers. Let's say it's like 3, -2, 1, -1 maybe, and then like 4 or something, right? And let's look at different indices we could start at. So if we start here, how much gas would we have at the end of this array? Let's just say. So we'd start off with 3, we'd subtract 2, we'd have 1, we'd have 2, subtract 1, we have 1, and then we have 4, so we have 5. by the time we get to the end of this array. Now, if we start at -2, obviously we can't start at negative index. And then if we start at -1, we'd have 4, right? So we'd have 1, -1, 0. And then if we start 4, we have 4. So the way to figure this out really is you have to know that if you have some positive net gas, as long as that value is greater or equal to 0, that's going to be our optimal solution. So we can just pick some index starting from the front, and as long as we keep adding up these nets, as long as that stays positive, that's guaranteed to be our optimal solution. Because as long as we have a positive value, right? So whenever we add some value, let's just call that V. Whenever we add some value, as long as our current value, let's call that C, is greater than or equal to 0, we are better off starting at this C than at this V, right? Because if a positive value plus a positive value is going to be guaranteed to be bigger than just this value on its own. This is kind of like a Kadane's algorithm, right? If you have a positive sum and you're adding a positive number, you never want to replace that number. You never want to replace that sum with that number. You always want to keep adding. And so that's kind of the intuition for this problem is we're going to keep going through. We're going to make this so we don't really need to make this n array. We can just make this on the fly, right? We can just simply subtract cost minus gas and we can make it on the fly. And then we could say anytime. So remember, the other thing you have to know, by the way, is if we have more gas than cost or equal, I believe, if the sum of this G is greater than or equal to sum of cost, then we have to have a valid solution. It's guaranteed because we have more gas than cost. So there is some way, somewhere to start that there's a valid solution. So we're going to check first if G is less than or equal to cost. If not, we can just return it's not possible, right? We just don't have enough gas. But if it's greater than or equal to, you can try different values, but you're never going to have a case where G is greater than or equal to C and you don't have a valid solution. And I'd encourage you to try this out. It's not super intuitive, but that is the way that it works. If the sum of G is greater than or equal to C, there has to be some starting index. And we just have to maximize like the amount of gas we get at the very start, right? That's going to be our like greedy algorithm. We're going to maximize the gas we get at the very start by just making sure that our difference stays positive. And if our difference stays positive, then we're guaranteed to get the optimal solution. So we would start here. We would say like, okay, our difference is 3. It's positive. Great. Okay, our difference, we subtract 2. Our difference is 1. Positive. Great. Now our difference is 2, great. Our difference is 1, great. Our difference is 5. And then we just say, and then every time, so let's say we did hit some negative index. Like obviously the solution wouldn't work, but let's say we hit something like this. So what we're actually going to do is if we hit some negative index, we can just say that our solution is going to be the index after that. And eventually we're going to hit a case where that's not the case, but that's just what we're going to do. So if we hit this index, we say it's negative, we'll just say, okay, our new solution is this index. And then we reset our sum. So we don't, because this is negative, we want to restart our total, right? We want to start at the best place possible. And so the best place possible isn't going to have a negative number. So we'll just say, if we hit this -3, okay, our sum is negative. Let's just say the index is this number here. Okay, now this sum is -2. Okay, we don't want that. So let's just have our starting index over here instead. Okay, our sum is 1. We subtract 1, 0, and then we have 4. And so obviously for this, like I didn't plan this out to be a one solution thing, but technically anything that these two indices would be an equivalent solution. And so that would never really work in practice, right? You should never really have the same sum at two different indices. Otherwise there'd be like 2 solutions or no solutions or whatever. But in the problems they give us, they say there's only one solution. So there is going to be an optimal starting square, and the optimal starting square is the one that keeps the sum positive the entire time. Because like I said, when we add a positive number to another positive number, that's going to be that's going to be the best case scenario. Okay, so let's try to code that up. I understand it definitely is a little unintuitive, but once you know that when you have the sum G is greater than or equal to sum C, that you actually have a viable solution, then it makes a lot of sense to try to figure out where you want to start from. And yeah, knowing Kadane's algorithm that while your current sum is greater than or equal to 0, that's always going to be the thing we're going to want, because if we do get a positive number after that, we're going to want to add to the sum. We're not going to want to replace it. The only time we want to replace the sum is when our current sum is negative. Okay, so let's start coding here. So first of all, like I said, we can just say that if some cost is greater than some gas, we can just return false right away, and they want us to return -1. Okay, perfect. Now we want to have an index, right? So we're just going to have our res equal to 0 to start, and then we're going to go through our cost and gas, and we are going to get the differences, right? And so that's pretty straightforward. So what we can do, I think we can actually zip these up, right? I haven't used a zip in a while, but let's just do that. So how would we do this? So for, actually, I don't think we want to zip them up because I think with a zip you can't have an index, and we do want an index. So let's just use a for loop instead. For I in range length gas, let's say. So here, and then we also do want to have a total maybe, or sum or something, where we're going to keep adding numbers and we're going to see, do we have a negative number or not? So total plus equals, and then remember it's going to be cost I. No, it's going to be gas I minus cost I, right? Yeah, because gas would be positive and cost is negative. Yes, the total is this. Now, if total is negative, so if total is less than 0, now we just say, okay, that's fine. Let's just make our result the next value, and then it would have to have some solution. So we're never gonna have some case where we're at this value here and we don't have a solution yet. Like this has to have a solution. So it's okay to just make it the next value, and we're never gonna be out of bounds. Because by the time we get here, if none of these were a solution, then this would have to be the solution. Okay. And so if total is less than 0, then we have res plus equals 1, right? We'll just try the next index. Actually, no, we don't want res plus equals 1. We want res equals I plus 1, right? We want the next index from where we're at, not just the next index from where we started. Okay, so if that's the case, res equals, and then we reset the total, right? Because we have some negative total. So like in our picture, if we have some negative total, like here, we just say, okay, if this is negative total, we're going to reset it, and we're going to make our new starting index this index, and so on. Okay, so that's going to be total equals 0. Yeah. And let me see if I miss anything. So we definitely need to return res here, but let's just see if we miss anything. Now for in range gas, total plus equals gas. If total is less than 0, we update it. I think that's it, but let's see if we screw anything up. Cool. All right, cool. So as you can see, like I said, the trick to this problem is figuring out that if gas is greater than or equal to cost, you have a valid solution, and we just do it the greedy solution. And the greedy solution is right from the picture, just the one that starts at a positive number that ends up being positive at the end. So whenever we get a positive number, we just keep summing it up, and if we get a positive result, that's going to be the best place to start. Okay, and then let's think of the time and space here. So time, this is pretty straightforward. And definitely these greedy problems are a bit tricky because you just have to kind of try a greedy solution, and then you have to see if it works. And then usually what happens is they'll give you some edge case where your greedy solution fails, and then you'll realize, oh, for this one thing, it didn't work. But in this case, it does. So I definitely think greedy problems are some of the trickiest because it's very hard to find edge cases for sure. Okay. And so for time, we are just going through the gas and cost array. They're the same size. So let's just call that n, where n is the length of gas, and space. We're not storing anything, so space is of 1 here. So I think that's all for this problem. And if you like this video, please like and subscribe. It helps grow the channel. And thanks for watching, and I'll see you in the next one.